Section 9.3, continuation. And let's look at an example for right now. Okay, suppose we had 2 times 3x minus 1 minus x plus 3 equal 5x minus 2 times x plus 3. Let's say we had that. Okay. So, on your test, when you would see this on that first test, what would you do? What would be the first thing you would do? Distribute.
Oh, you're gonna distribute.
Olivia?
I'm seeing if these are the ones that we turned in.
Okay, so you distribute, right?
Yeah.
Okay. All right, so then that first part that you would write, because remember it's going to say show work as presented in class. So what you need to write is this. Tell me what to write.
6x minus 2.
Very good. What's the next one? Okay. Minus 3 because, hold on. Remember there's no number that's understood to be a 1. So in this case you would be distributing a negative 1. So negative 1 times x is negative x. Negative 1 times 3 is a negative 3. Equal? Then what'd you write over here?
5x minus 2x minus 6.
Very good. All right, so that's what all of you needed to have shown. Okay, now, all of you in the next step need to say what? Combine like terms. So on the left, what is it that you would write? Okay, because 6x minus x is 5x. What else? Minus 5, because then and when you add your constants, a negative 2 and a negative 3 is a negative 5. Okay, good. Equal. What would you write on the other side?
3x minus 6.
Because 5x minus 2x is 3x. All right, so that's where I'm at. Okay? So all of you need to have said that. Now, notice that this linear equation, there are variables on both sides, constants on both sides. It does not matter which side you bring the variables on or which side you bring the constants on or which you do first. Does not matter. So I'm not going to do all the possibilities, so you tell me what you want to do first.
Subtract 3x.
So you want to bring the variables to the left. That's what she wants to do. She wants to subtract 3x, so she wants to bring the variables to the left. Now, if you brought the variables to the right, you would end up with a negative 2x. Keep that in mind. But since she's bringing it to the left, she's going to end up with a positive 2x. All right, so now some of you, many of you can right away determine what to do, but some of you need to ask yourself, is adding 3x or subtracting 3x going to help? Subtracting. Adding 3x is not going to help because 3x plus 3x is 6x. So you got to subtract 3x. And notice I'm aligning my like terms. So that's what all of you need to do. Now there's 1 or 2 that keep drawing arrows. If you keep drawing arrows, I'll keep taking points off. Okay? You should not be drawing arrows. That's not what we're doing in class. All right. So this is what you need to say. Now, what property did I just use? Addition property of equality. So what I add to one side, I add to the other. What's the next thing I've got to do, though?
Combine like terms.
Yes. What's 5x minus 3x?
2x
So what will be the next thing you need to write right here? 2x.
minus 5
Very good.
equals negative 6.
Equals negative 6. All right. A couple more steps and you're done. What's the next step?
Add the 5 to both
Add
sides.
5 to both sides. Okay? So right now I'm subtracting 5. The opposite of subtracting 5 is to add 5. So you're going to add 5 to both sides. And so when I combine like terms, now again, just to remind you, this is what property they just used? Addition property of equality. That's what I just used. Now you don't have to write that on the test, but I'm just reminding you what property you're using. And you use it here as well. Okay, so now you can combine like terms. Negative 5 and a positive 5 is 0. What's left on the left?
2x.
Okay, what do I get on the right when I combine them? Negative 1. All right, and then finally, what's the next step?
Divide by 2.
Right, because right now to get x by itself, right now I'm multiplying by 2. The opposite of multiplying by 2 is to divide by 2. So you can divide both sides by 2. And I'm just going to go ahead and and rewrite this statement. 2x equals negative 1, so I'm going to divide both sides by 2. And remember, 2 divided by 2, that's not 0. What is that? 1. 1 times x is x, and what does x equal? Negative 1 half. Not negative 2, negative 1 half. So that's your solution. Okay? All right, so just make sure you can do something like this on test number 1. Now, test number 2 is where you can have some fractions where you have to clear the fraction. That's what the very last thing we did in class was that idea. That will be on test 2. Okay? All right. Now, okay, so towards the end, I'll give you that study guide. And basically, it's going to just say, look at this worksheet, and so on. All right, now let's look at this. This is number 26 on page 648. I'm going to do this two ways. So 26 looks like this. It's 5 halves. 5 halves x minus 1 equals x plus a fourth. Okay, now the way you learned it at this point in here, the way you learned it was you brought all the variables one side, constants the other. Okay? And so what you did before was you said, all right, I'm going to subtract x from both sides, just like this. All right? And what property did I just use? Okay, now what's the next thing I've got to do? All right, so what is 5 halves subtract 1? Use your calculator if you don't know it. 5 halves subtract 1. What is it? 3 halves. So what is 5 halves x subtract 1x? 3 halves x. Minus 1. When I combine these, that's 0 right here because an x and a negative x is 0. And what's 0 plus a fourth? 1/4. So that equals 1/4. All right? So that's what all of you would write. Now, what would be the next thing all of you would write?
Subtract one, add one to both sides.
Add 1 to both sides. That's what all of you would write. So that's the addition property of equality. That's what I'm using. So right here and right here. And then you can combine like terms. When I combine like terms on the left side, negative 1 to positive 1 is 0. So you're left with 3 halves x. Equal? Now, if you don't know what 1/4 plus 1 is, use your calculator. What's 1/4 plus 1 and write it as a fraction?
5/4.
5/4. Okay, 5/4. All right, so that's where we're at. So that's what all of you need to write. Now, what's the next thing that all of you would tell me on that test? 1. Divide both sides by 3 halves. So I'm going to go ahead and rewrite this statement. So what property am I using when I divide both sides by 3 halves? Just like this. The multiplication property of equality. That's what I'm using. Multiplication property of equality. Okay, so 3 halves divided by 3 halves is 1. 1 times x is x. Now let's use what we learned last semester. I'm dividing fractions. So whenever you divide, you're going to change it to multiplication. So you're going to take the fraction that's in the numerator, 5/4, and multiply it by the reciprocal of the fraction that's in the denominator, 2/3. Okay, that's where I'm at. Now, remember, if you can reduce, you reduce first. Now, you don't have to reduce first, but it sometimes helps. Now, in this case, since the numbers are not that big, it's not going to matter. So if you didn't reduce, you would say 5 times 2 is 10. 4 times 3 is 12. But then you'd have to reduce that. So 10 12, they're both divisible by what? 2. So 10 divided by 2 is 5. 12 divided by 2 is 6. Now, if you had reduced first, so that's your solution here. So x equals 5, 6. If you had reduced first, You would say 2 into 2 is 1, 2 into 4 is 2. And then, what was that? Yeah, so 5 times 1 is 5, and then 2 times 3 is 6. You get the same thing. Okay? So that's what we learned in the previous section.
I thought 6 times 3 was 18.
You thought what now?
I thought 6 times 3 was 18.
That's not a 6, that's a 4. Okay. Now let's do the same problem using the idea we were talking about last class period, because that's going to, you have to know how to do that. So, the steps at this point is going to be this. So these are your general steps solving linear equation. All right, so general steps solving linear equation. Okay, first one. If you have parentheses, clear the parentheses. So you're gonna clear the parentheses using distributive property. Okay. Then the next thing you're going to do is you're going to clear the fractions by multiplying both sides by the LCD. Okay. Now, once you do that, it's going to look like this. It'll look like this. So then I'm going to write use the addition property of equality. So the third step would be to use the addition property of equality. To get the variables to one side, constants to the other. Use the addition property of equality to get the variables on one side, and constants on the other. So use the addition property of equality to get the variable to one side, constants to the other. And we've been doing that. When you had all these linear equations, you brought the variables to one side, constants to the other, and you use the addition property of equality to do that. So step 3 is not new, step 1 is not new. The only thing that would be new to you is which step? Step 2. That's the only thing that would be new. Now, once you get the variables to one side, the next step, remember, was to use the multiplication property of equality. That's where you divide both sides by the coefficient. So step 4 would be to use the multiplication property of equality to solve for the variable. All right, so you can use the multiplication property of equality to solve for the variable. All right? Okay. So the only new step here would be step 2. That's the only new step. Okay, so let's go back and do the same problem, number 26. And we're going to do it using this. So here's 26. You have 5 halves x minus 1 equals x plus a fourth. Okay. All right, now, on one of the worksheets, it's going to say clear the fractions using the LCD. So if it says that, you have to use this process right here. You cannot do this. Yes?
Can you reread number 3, please?
Number 3, use the addition property of equality to get the variables on one side and constants on the other. And number 4 is use the multiplication property of equality to solve for the variable. Okay, so if the direction says solve the equation by multiplying both sides by the LCD, then you have to use this. You cannot use this because nowhere did I clear the fractions. I just kept dealing with fractions, see fractions all over the place. Okay? All right, so let's talk about how to approach this. All right, first of all, are there any parentheses? No. Okay. Secondly, are there fractions? Yes. So I've got to look at all of the fractions on both sides. And technically, you got to look at every term. How many terms on the left? We're talking about terms. That was one of your worksheets. 2. That's 5. Now remember, 5 halves x technically is the same thing as saying 5x divided by what? No. 5x divided by 2. This is 1 divided by 1. This is x divided by 1. This is 1 divided by 4. All right, so I'm going to talk about the denominators. What's this denominator here? 2. What's this denominator here? What's this denominator here? What's this denominator here? So what's the least common denominator of all of those denominators? 4. Very good. So the smallest number that 2, 1, 1, and 4 go into is 4. Okay? All right. Now, what you're going to do is this. And we kind of did that idea last class period, so you may have forgotten it, though. Now you got to multiply, to clear the fractions, you're going to multiply both sides by that LCD. But how many terms are on the left side? 2. So you have to enclose it in parentheses. You have to put parentheses around. We talked about that at some point last class period. So it's got to look like this. So I'm going to go ahead and rewrite the left side. And I'm going to put that in parentheses just like this. So if you have more than one term, you have to put in parentheses, and there's a reason. And on the right side, how many terms do you see? 2, but more than one, right? So I have to put that in what? Parentheses. And the reason is this. Everything has to be multiplied by what? 4. And so since everything has to be multiplied by 4, that means I have to use what property? And in order to use a distributive property, I have to have all of this in parentheses. All right, so that's the way it looks. Okay? So notice I'm doing step 2. I'm multiplying both sides by what? The LCD. But you got to remember, you got to put parentheses there. You have to enclose both sides in parentheses because everything has to be multiplied by 4. Now let's use a distributive property. Okay, now watch when we do that, the whole idea of multiplying by the LCD is get rid of those fractions. So that will be the next thing. You better make sure that there are no fractions left. That was the whole point. Okay, that was the whole point. If you look at this, I dealt with fractions throughout. The idea here is to get rid of the fractions. All right. So what is 4 times 5 halves? Let's say it again. 10. But 4 times 5 halves is 10, right? You're going to say, you can say 4 times 5 is 20. 20 divided by 2 is what? 10. Or you can reduce first. 2 into 2 is 1. 2 into 4 is 2. 2 times 5 is 10. So what is 4 times 5 halves x? 10x. Notice I don't have any fractions in that first term anymore. I clear that fraction. Now what's 4 times negative 1? What's going to be the next term? Right. Now a common mistake people make is that they write it as minus 1. It's incorrect. Everything has to be multiplied by 4. Equal? What's going to be that first term on the right side? Good. Now, what's going to be the second term on the right side? We're saying 4 times what? 1/4. Now, some of you are going to say 4 times 1/4 is 16 because you're not really looking at it the way you need to look at it. It's not saying 4 times 4. It's saying 4 times what? 1/4. 4 times 1/4 is 1 because that's really 4 over 1, right? Okay, and 4 divided by 4 is 1. So that should be 4x plus 1. So now notice, it now looks like a simple equation you did a while back. No fractions anymore. And then step 3 and 4 is where you use the addition property of equality and multiplication property of equality. So that's where we're at. So the new step is step 2. Now we're going to do it like we've been doing. So you had to turn in a worksheet today that dealt with this step here that we were doing right here. So what's the next step? You want to bring the variables to the left, or you want to bring the variables to the right? It doesn't matter. To the right? Okay, we can do it to the right. Notice what happens, though. You got to be careful. You're going to get a negative coefficient for x. That's fine. It doesn't matter, and it helps to do it both ways. Not both ways each time, but to know how to deal with it when that other situation occurs. So you're going to add 10x or subtract 10x? Subtract 10x. Notice I'm aligning my like terms. What I do to one side, I do to the other. And remember, the direction is going to say as presented in class. Okay? So don't lose any points because you didn't do it the way that we did it in class. Combine like terms. What's 10x minus 10x?
0.
What's 0 minus 4?
-4.
Good. Now be careful. What's 4x minus 10x? Negative 6x. And then plus what? 1. So that's where I'm at. What's the next step?
Subtract 1.
Subtract 1 from both sides. I'm aligning my like terms. So remember, I'm using the addition property of equality. That's what I'm using here, the addition property of equality. You're here and here. And then at each point, remember, whenever we did the addition property of equality, almost all the time, we combine like terms next. What's negative 4 and a negative 1? Okay. Equal? Negative 6x, because 1 and a negative 1 is 0. And in one more step and you're done. Now what property do I have to use next? Multiplication property of equality. So how do you get the variable x by itself? Divide both sides by negative 6. Just like this. And you got to remember that a negative divided by negative is a positive. So, and then also negative 6 divided by negative 6 is 1. 1 times x is x. And what's the answer? 5, 6. That's it. Notice the steps, though. For the most part, all of you are going to show the same steps. Okay, so the new thing is clearing the fraction. I'm multiplying both sides by LCD. Notice we enclosed each side in parentheses since there was more than one term. All right. Okay, let's look at 24. 24. Okay, let's do 24 using that same approach. Number 24, using the same approach. And on the worksheet, there's one problem that looks like that. So if you want to do 24 like we're doing now, that's fine. So 24, you have 3y plus 3 divided by 5 equals 2y plus 6. All right, so let's do what we're doing, that process. I do have fractions, so let's do this by clearing the fractions. Okay, but what's that first step? Distributive property, because I have parentheses. So what's going to be that numerator? 3y plus 9. All divided by 5 equals 2y plus 6. All right. Now if you look at this, I have one fraction here, you see that? And what's that denominator? 5. Over here, I have two terms, and each one has what denominator? 1. So what's the LCD? 5. So the LCD is 5. Now once I find the LCD, then I'm going to multiply both sides by it. Okay? Now remember what we just said. How many fractions do you see here? 1. Okay. How many fractions do you see here? 2y divided by 1 plus 6 divided by 1. How many do you see here? 2. So 2 terms, right? So you got to put this one in parentheses. This one you can leave alone for right now because this is one fraction. You see that? Now, if you wanted to, just letting you know, if you wanted to, just want to show you this, and there's nothing wrong with it. If you wanted to, you can write this as 2 fractions. Because you can write this as 3y divided by what? 5 plus 9 divided by 5. See how it looks? Okay. But I would just leave it like this for right now. All right. So, since this is one fraction, I'm going to leave it alone for right now. I'm just going to rewrite it. I'm not going to put parentheses. Equal. Now I'm going to put parentheses here because it kind of looks like this, doesn't it? Two things. Okay. And I've got to do what to both sides? Multiply by what? 5. All right, so here I'm going to rewrite this. So, well, actually, I'm going to do this. So I'm going to say times 5 times 5. What you do one side, you do the other. That's how it looks. So you can say times 5 times 5. Now, the left side's easy because remember the whole point of multiplying by the LCD is to clear the fractions. So when I reduce, it clears the fraction. When you reduce, your fractions are cleared. In other words, you get 1 in that denominator. So watch. 5 into 5 is what? 1. 5 into 5 is 1. And 1 being here is the easiest kind because 1 times this numerator is still what? That numerator, so still 3y plus 9. So I get 3y plus 9 over here. But notice, I no longer have that denominator 5. Okay? Equal. Now how do I get rid of this? Distribute. So notice I use the distribute property here. I enclosed, when I use the LCD, since I enclosed this side in parentheses, I've got to use the distribute property again. And what do I get? Plus 30. So that's where I'm at. So notice I don't have any fractions anymore. I don't have any fractions. And now the third and fourth step is what I do. So do you want to bring the variables to the left or the right?
Right.
The right? Okay, so you're going to add 3y, subtract 3y. Say it again. Adding 3y is not going to help. 3y plus 3y is not 0. So what are you going to do? Subtract 3y from both sides. And they combine like terms. What's 3y minus 3y? What's 0 plus 9? Good. What is 10y minus 3y? And then plus what? 30. Now, when I was, some of the worksheets that you're getting back, you'll notice, and I mentioned this in class, don't say 3y subtract 3. You got to say 3y subtract what? 3y. Because 3y subtract 3, those are not like terms. You're not subtracting 3, you're subtracting what? 3y. 3 and 3y are not the same thing. All right, so that's where I'm at. Now, a couple more steps and you're done. What's the next step?
30.
Subtract 30. Just like this. And what's 9 minus 30? Okay. Equal? Good. And one more step and you're done. Divide both sides by 7? All right. Right. Now, what I used here and here was the addition property of equality. So that's step 3. That's step 3. And now I'm using step 4. So step 4 is to get the variable by itself. So I'm going to divide both sides by 7. So that's multiplication property of equality. 7 divided by 7 is 1. 1 times y is y. Equal. And what's the answer? Negative 3. So that's your solution. Solution is negative 3. All right, let's look at 44. 44. Okay, 44. All right. You have 5 times x minus 1 divided by 4 equals 3 times x plus 1 divided by 2. So 5 times x plus 1 divided by 4 equals 3 times x plus 1 divided by 2. All right, so what's step 1?
It's the x plus 1 in the first distribute.
Say it again. What's step 1?
Distribute.
Distribute. Distribute a property. So what's going to be the numerator? 5x minus 5, and the denominator is what? 4. Equal. What's the numerator here?
3x plus 3.
Divided by 2. All right. So that's step 1. Step 2, I have fractions, right? So let's clear the fractions. What's the LCD? 4. Now again, think of this as one fraction, just like we did in the previous one. One fraction, one fraction. So I'm not going to use parentheses at this point. At this point, I'm not. I may still have to, but I'm not at this point. Okay? All right, so LCD is 4. All right, now watch carefully what I'm doing. 5x minus 5, I'm just rewriting it over. All right, so I just rewrote the problem. So I'm going to say times 4 times 4, right? Agree? Okay. Now, the whole point of multiplying both sides by the LCD is to clear that denominator, to make that denominator 1. So watch what happens on the left. 4 into 4 is 1. 4 into 4 is 1. So, based on our discussion a while ago, what do you think is going to be on the left side of this equation?
5x minus 5.
Very good. 5x minus 5. All right, because 1 times the numerator is still that numerator. Okay? So, there shouldn't be any difficulty with the left-hand side. All of you should have gotten 5x minus 5. Now, on the right, you need to be careful. 2 into 2 is 1. That was the whole point. Remember, the whole point is to get the denominator to be a 1. And you do that by multiplying both sides by the LCD. 2 into 4 is 2. Okay, now I'm going to ask this. What's going to be the right side of that equation?
6x plus 6.
Think it's 6x plus 6? Anybody else?
Yeah.
Okay, it is 6x plus 6. Now, the mistake people make is this, and here's what I'm going to tell you. You can go from here to 6x plus 6, I'm not going to have an issue. But some of you are going to say this is 6x because it says 2 times what? 3x. And 2 times 3x is what? 6x. But you're going to say 6x plus 3, and it's not 6x plus 3, it's 6x plus 6. So technically what's happening is that everything in here, you're multiplying by what? 2. So if you need to, put that in parentheses right here. Now, if you know how to do this without putting parentheses at this step, then that's fine. You may say, why do you put parentheses here? Because that was a 1, and 1 times anything is what? That thing. Now, you could I have put parentheses around here? Yes. But what's 1 times 5x?
5x.
What's 1 times negative 5? 5. It doesn't matter. But you got to be careful when you reduce, and this is no longer a 1, because everything in that numerator has to be multiplied by 2. Okay, so what's this step right here? 6x plus 6. So I really used the distributive property there. So I used the distributive property here in the original part, step 1, and I used it here. Okay. All right. Now what's the next step? Do you want me to see they're no longer any fractions? So that's the easy kind. So now this is easy. You want to bring the variables to the right or the left? I'm going to bring it to the left. Okay. Bring it to the right would have been easy. But let's do the left, because some of you need to know how to deal with that, with what you see. But you understand that bringing it to the right would have gotten us what? A positive 1x, or just x, which is what we want to end up with. But if you want to bring it to the left, that's fine. Some of you need to see this. Now remember, I'm using step 3, and step 3 is what property? Addition property of equality. What's 5x subtract x? 6x? Negative x, or negative 1x, right? Minus 5 equal. And what's left on the other side? 6. What's the next step? Add 5 to both sides. Combine like terms. So I get negative 1x, negative x, negative 1x, equal 11. But how do you get x by itself? Divide both sides by what? Negative 1. Now, some of you in that worksheet, you divided by negative 1x. You don't divide by negative 1x, because negative 1x divided by negative 1x is not x. Anything divided by itself is 1. You got to divide by the coefficient only. So the only thing you need to say here is divide by what? Negative 1. So you got to look at why I circled some of these things on that worksheet. Okay, so it's kind of like saying this. I want to make sure you understand this. If I have 7x equal 14, okay? Some of you did this. Some of you said, I'm divided by 7x. And then you said this, and then you said, well, x equal 2. That is not true. That is not a true statement. Because what's 7x divided by 7x? 1. You're saying that's equal to x. That's not x. Anything divided by itself is 1. What you meant to say, divide by 7. Because now 7x divided by 7 is what? X. And 14 divided by 7 is 2. So you got to make sure mathematically you say things correctly. This is not mathematically correct. Okay, so what is negative 1 divided by negative 1? Over here?
X.
Negative 1 divided by negative 1 is not x. Just tell me, answer the word. Negative 1 divided by negative 1 is 1. 1 times x is x. And what's 11 divided by negative 1?
11. Negative 11.
Negative 11. Okay? That's your solution. So you got to practice with this. So just watching is not going to help for many of you. You got to practice with this. Okay, let's do 52. 52. And we're going to do 52 using that same procedure, steps 1 through 4. Okay, 52. All right, 52, you have 7/8x plus 1/4 equals 3/4 x. So 7/8x plus 1/4 equals 3/4 x. Do I do step 1?
Each variable on the same time.
No. Well, I want you to use that. I want you to use the steps we've been doing.
7, 8, X.
So I'm asking, do I do step 1?
No.
No, because there are no parentheses, so I don't use distributive property at this point. Step 2 says I got to do what? Clear the fractions. What is the LCD?
8.
8. Okay, so the LCD is 8. And now we multiply both sides by 8. Now I'm going to ask you this next question. Which side do I need the parentheses on? The left. The left side I need it on. So times 8, times 8. Okay? And remember, the whole point of multiplying by the LCD is to clear those fractions. And let's use distributive property now. What is 8 times 7/8? 7. Remember, the whole idea was to clear that fraction. So what is 8 times 7/8 x then? 7x. Plus, what is 8 times 1/4? 2. What'd you say? 2, right? Because this is 8 over 1. 8 divided by 4 is 2. So that's 7x plus 2 equal. Now over here, what is 8 times 3/4? 6. Because 4 into 4 is 1. 4 into 8 is 2. 2 times 3 is 6. Or you could have said 8 times 3 is 24. 24 divided by 4 is 6. So that's 6 what? X. And that's where I'm at. So I clear the fractions. All right. Now tell me what you want the next step to be. Okay, so I'm using third step from addition property equality, so you can subtract 7x from both sides. Then I'm combining like terms. What's 7x minus 7x? What's 0 plus 2? What's 6x minus 7x? Negative 1x. Good. One more step and you're done, because remember, try to get x by itself. What's the next step? Divide both sides by negative 1. Negative 1, not negative 1x, but what? Negative 1. You should be dividing only by the coefficient. And then finally your answer is, what's negative 1 divided by negative 1? Negative 1 divided by negative 1? 1. 1 times x. And what's 2 divided by negative 1? Negative 2. Okay. All right.
And how will it read on the test when you want us to work it out that way?
Okay, so on one of the worksheets, You're going to see that today, I think. Yeah. One of the worksheets is going to say solve the equation. It's going to say show work as presented in class. It's also going to say solve the problem multiplying both sides by the LCD. So if it says multiply by the LCD, that's those steps here. Step 1, 2, 3, 4.
You have to say that on the test as well.
Yeah. So if it doesn't say anything like that, then remember a while ago some of you said let's bring the variables to one side. You could. So in other words, you're using what you did in the previous lesson. That's fine. But that's why reading the directions is important.
That would just be like solving a regular linear equation.
Okay? All right, now, look at this. Okay, listen carefully. So if you go back to all the problems we've done, remember, this is a linear equation. All those were linear equations. When you go back to all the problems we've done, though, how many solutions were there? 1. For every one of them, there was one solution. Okay? All right. Let's look at this. This is going to be number 32. Number 32. Okay, listen carefully as we do this. X divided by 3 minus 2 equal x divided by 3. Okay? Now, I'm not telling you what approach to take. So you tell me what you want to do here. Do you want to clear the fractions, or you just want to bring the variable to one side, constant to the other?
Does it matter?
Does not matter because I'm not giving you any directions here other than to solve the equation and show work. Clear the fractions? Okay, so there are no parentheses. I'm not going to use the distributive property. I do have fractions. What's the LCD? 3. So I'm going to multiply both sides by 3. Which side do I need parentheses? Left, right, or both? Left, because I have two terms here. Okay, so I had to put parentheses here because that's more than one term. So I'm going to say now I'm going to multiply by 3 times 3 times 3, just like this. Okay. Now I'm going to use what? Now what property am I going to use next? Distributive property. What is x times x divided by 3? It's just x. 1x or x. I prefer you write as x. It's x, right? Minus, what is 3 times 2? Minus 6. X minus 6. Equal. What's 3 times x divided by 3? X. All right, so that's where I'm at. So I clear the fractions. Now I'm going to use step 3. What's the next step? You can. I wouldn't do that. I would just quickly do what now? Subtract x from both sides. Then combine like terms. What's x minus x? And what's 0 and a negative 6? What's x minus x? No. 0. Right? Okay, now I want you to notice something. What do you notice? The variables are no longer there. Right? The variables aren't there any longer. Whereas before, you ended up, in your last statement, you ended up with x or y, whatever the variable is, equal a number. So you had a solution. So I want you to look at the statement. What do you notice about the statement negative 6 equals 0? Is that a true or false statement? That's a false statement. That statement is true. So that means in terms of your solutions, you would say there are no solutions. There's no solution. So you'd say no solution. No number will make the original problem true. And I want you to see why. Okay, watch. So no solution, okay? So that's what you put in the blank, no solution. Because this is what kind of statement? It's a false statement. Now in the blank, don't put false. You put what? No solution. Okay, but I want you to understand why it's true. You see right here, these two terms are alike? And then all of a sudden I'm subtracting 6 from both sides, 6 from the left. Well, if this is 8 right here, and this is 8, and I subtract 6, this side is now what? 2, and this side is still what? 8. If that's 10 minus 6, which is what? 4, and this is still what? 10. Is 4 equal to 10? No, no number will work. Okay? So that's no solution. So here's the thing. When you solve the equation and the variables disappear, you want to look at your statement. Right now, all we looked at was a false statement. A false statement, you're going to say what? No solution, because no number will work. No matter what number you put into this equation or this one here, you'll see that nothing works.
Are we gonna have an option to solve it however we want to solve it?
You mean here?
Well, yeah, if you did it the other way, would it work? Without finding the common denominator?
Yeah, so if you did this, so if you subtract x divided by 3 from both sides, see that? So if you subtract x, look, this is what she's asking. Okay, it's a good question. So if you subtract x divided by 3, x divided by 3, subtract x divided by 3 is what? What's 0 minus 2? Equal? What's x divided by 3, subtract x divided by 3? Variables disappeared, right? Okay? Then the question then becomes, all right, what solutions do I have? Well, what kind of statement is that? It's a false statement. So you're going to say what? No solution. Okay, no solution. All right, now let's look at this one. This is going to be number 48. 48. Okay, you're going to have, you have 3 times 2x plus 1. Oh, sorry, 2x minus 1. Plus 5 equal 6x plus 2. So in my math lab for this section, there are some that's going to be no solution, and there are some that's going to look like number 48. So you can see what that's going to look like. Okay, what's the first step? Distributive property. So if I distribute the 3, what do I end up with over here? Then plus 5, right? Equal, and then 6x plus 2. Y'all agree? Okay. What's the next step?
You combine your,
Like terms.
yeah, like
So what do I get?
6x plus 2.
Equal. All right, so that's where I'm at. Okay. Now, you're so much in the habit of getting the variable by itself that you're probably going to subtract 6x from both sides, right?
Yep.
Okay, fine. When I do that though, and I combine like terms, what's 6x minus 6x? And 0 plus 2 is 2 equal, that's 0, and what's that equal to? 2. Notice the variables disappeared. But now, what statement is this? It's a true statement. So what that means in terms of your solutions is that any real number works. So it'll be all real numbers.
So it's a true statement because it equals itself,
Yeah, 2 equals 2.
even though there's no X or Y or.
Right, that's a true statement. 2 equals 2. The previous one, 0 did not equal 2. That was a false statement. Okay, that's a true statement. Whenever you get that true statement, whenever the variable disappears, and that's a true statement, what that means in terms of your solutions is that any number works, any real number. So watch what happens. So in the blank, you're going to say all real numbers.
Are you giving us these choices, or do we have to know this?
I'm sorry, what do you mean by choices?
In other words, we have to know to write all real numbers?
Yes, you have to know how to write all real numbers. Okay? All right, so watch. Let's pick 5, okay? Let's say 5 is a solution. Let's check 5. Go back to the original. What's 2 times 5?
10,
What's 10 minus 1?
9,
Okay, what's 9 times 3?
27,
27. What's 27 plus 5?
32,
32. All right, so the left side's 32, right? What's 6 times 5?
30,
And what's 30 plus 2?
32,
So left equals right. Let's try 8. What's 2 times 8?
16,
What's 16 minus 1?
15,
17. What's 17 times 3?
16 minus 1.
8 times 2 is 16. 16 minus 1 is 15. What's 15 times 3?
45,
45. What's 45 plus 5? 50. What's 6 times 8?
48.
48. What's 48 plus 2? That's 50 equals 50. So 8 is the solution. Do you see that any number I can plug into X will work? Okay. So decimals will be solutions. Whole numbers will be solutions. Integers will be solutions. Any rational, irrational number works. Okay? So all real numbers. All right. So So in my math lab, there are several problems where the variable disappear. If the variable disappear, either you're going to get no solution or what? All real numbers. If that statement where the variable disappear, if that statement is true, is going to be all real numbers. If the statement is false, you're going to say no solution. Now let me just say this. You could have stopped here. Could have stopped here. Because what do you notice about these two sides? They are identical. 6x plus 2 equals 6x plus 2. That's an identical statement. So that means your solution is going to be all real numbers. So you could have stopped here and just said all real numbers. Okay? All right. Okay, so let me just show you what that worksheet looks like then.